Welcome to the College Mathematics CLEP review. In this video, I want you to get a feel for different types of problems you might see on the exam. So I included an example from each math topic that this test covers, which includes numbers, algebra and functions, counting and probability, data analysis and statistics, financial mathematics, geometry, and logic and sets. So the first area that this test covers is numbers. So you need to know the difference between rational and irrational numbers, factors. You need to know about primes and composites, even and odd numbers, unit conversion, scientific notation, and numerical precision. The example that I'm going to cover covers scientific notation. So in this problem, they wanted to know if 2.4 times 10 to the 6th power divided by 3.0 times 10 to the negative 4th power equals 8.0 times 10 to the n power, what is n? So what is n equal to? So this deals with scientific notation. We're dividing two numbers that are in scientific notation. So normally when you do that, you want to first divide the numbers 2.4 divided by 3.0. And if you do that, you get 0.8. So then you deal with the tens, and here you need to subtract the exponents. So you need to do 6 minus the negative 4, which will give you 10. So it's going to be 10 to the 10th power. Now for scientific notation, you really want this 8 to be out front. You want 8.0 times 10 to some power. So in order to do that, the decimal point is going to be moving one place to the right to give you 8.0. And when you do that, that's basically multiplying it by 10. So I need to reduce my exponent on the 10 power to 9. So this is equivalent to 8.0 times 10 to the 9th power. So n will equal 9. This test also covers algebra and functions. Here you would need to know how to solve equations, how to deal with linear inequalities, how to solve systems of linear equations, how to evaluate functions, how to interpret graphs of functions or even come up with a graph of a function, and linear and exponential growth. So in this problem, I ask you, what's the solution to 5 plus 3 to the x power equals 20? So here we want to know what x needs to be in order to make this equation true. So anytime you're trying to solve an equation, you need to isolate the variable. Now in this case, our variable is in the exponent spot. So anytime your variable is in the exponent spot, normally you have to end up using logarithms to get it out of there. So what I'm first going to do here is subtract 5 from both sides. Alright, that'll give me 3 to the x power equals 15. Now from there, I'm going to take the natural log of both sides. Okay, so that's a little trick you can use to get that x out of the exponent position. So once you have it in log form, there's a rule, power rule, where you can move the exponent, whatever's in the exponent spot, out front. So it becomes x times the natural log of 3 equals the natural log of 15. So from there, I can get x by itself by dividing by natural log of 3 on both sides. And that will isolate the x, giving you x equals natural log of 15 divided by natural log of 3. So that's how you solve that problem. The counting and probability section that deals with the multiplication rule, combinations and permutations, probability of different events, independent and mutually exclusive events, conditional probabilities, and expected value. So this one reads, a new computer graphics company employs 10 programmers. The company decides to expand into digital animation and needs to transfer 3 of the programmers into the new department. How many different combinations of 3 programmers can be chosen to transfer to the new department? All right, so this one deals with combination formula. Now if we look at that, we have NCR. So here N is how many you can choose from, and R is how many that you need to choose. Okay, so the formula for that is N factorial divided by R factorial times N minus R factorial. Remember, factorial, if I actually have 3 factorial, that means to multiply all the numbers down starting at 3 all the way down to 1 together. So 3 times 2 times 1, which will give you 6. If I had 10 factorial, I would start at 10 and multiply all the way down 9, 8, 7, 6, 5, 4, 3, 2, 1. Multiply those all together. All right, so in this one, we have 10 programmers, and we need to choose 3 of them. So our N is 10, R is 3. So that's going to give us 10 factorial, R is 3, so 3 factorial, and then 10 minus 3, which would be 7 factorial. Okay, so you can multiply this all out and solve it, or you can reduce it. If you look at 10 factorial, I got 7 factorial at the bottom. So what I can do is make it 10 times 9 times 8 times 7 factorial. So that's still just 10 multiplied by all the numbers going down to 1. And then I'll leave the bottom the same. What I can do here is cancel out the 7 factorials. That's going to end up giving me 720 on top and 6 on bottom, which comes out to 120. Alright, so this was a combination, not a permutation. Permutations, the order matters. So this is any 3 together. There's no spots within that 3. So this is just a combination. So your calculator actually might have a button for a combination, so you need to check out the manual for your calculator. Otherwise, you have to use this formula. Next section involves data analysis and statistics, which involves data interpretation, data representation, mean, median, mode, and range, standard deviation, and normal distribution. So this one says the difference between the mean and median of the numbers is what? So here the mean, so mean is kind of the same as average. Average, you add up all the numbers together and divide by how many they are. And the median is if you line them up from least to greatest, the one in the middle. And if you have 2 numbers in the middle, you take the average of those 2. So let's add these up. We have 27 plus 27 plus 29 plus 32 plus 35. And we have 1, 2, 3, 4, 5 numbers. So I'm going to divide by 5. So this comes out to 150 divided by 5, which gives us 30. So our mean is 30. Now these are already lined up from least to greatest, so the one in the middle is 29. So we want to know the difference between mean and median. Difference means subtraction, so 30 minus 29 gives us 1. This next section deals with financial mathematics. Here we got to deal with percent and percent change, markups, discounts, taxes, profits and loss, simple, compound, and continuous interest, interest rates, and APR, and present and future value. So this one says, what is the future value of $10,000 invested for 1 year at an annual interest rate of 2% compounded semi-annually? All right, so this deals with future value. Put $10,000 in, is earning interest, is going to be worth more in the future. So here you need to know the compound interest formula. And that is A equals P parentheses 1 plus R over N to the N times T power. So A is your future value, P is your principal, your starting amount, R is your annual interest rate, N is your number of compounding periods per year, again, number of compounding periods per year, N, and T is how many years. Okay, so we're going to plug in what we know. We know we're putting in 10,000 initially, so that's our P value, 10,000. And then 1 interest rate. Always put your interest rate in decimal form, so divide by 100 to give you 0.02. Semi-annually, so that means twice a year, so it'd be 2 compounding periods per year. If it said quarterly, that'd be 4 times per year. Monthly, be 12 times per year. Daily, use 360. And if it said just annually, that'd be 1 time per year. All right, so our N was 2, and we're just doing 1 year. All right, so that'd be 10,000. And that's going to be 0.02 divided by 2 is going to give you 0.01 into the second power. And if you put that in the calculator, you end up with $10,201. So this next part deals with geometry. So here you need to know properties of triangles and quadrilaterals, perimeter, area, similarity, the Pythagorean theorem, a squared plus b squared equals c squared, circle circumference, the distance around the circle, and its area, inscribed angles, and sectors. This one reads, the circle shown at center O and the measure of angle AOB is 45 degrees. If the area of the shaded sector is 18 pi, what is the radius of the circle? So for this problem, you need to know the formula for the area of a circle. And that's A equals pi r squared. So pi r squared, r is the radius. Now we're dealing with a sector, so we're not dealing with the whole circle. So we need to do, proportionally. So this is 45 degrees out of a total 360 degrees. So we know the area is 18 pi, so that's going to go on the left side. And we're trying to solve for the radius, so that's going to stay r. Now the 18 pi is only equal to the sector that's shaded, so that's 45 out of 360 degrees. So not the whole circle, just a part of the circle. Now we need to solve for r. Since we got pi on both sides, we can just divide by pi to get rid of them. So that leaves me with 18 equals 45 over 360 r squared. Now I get rid of the 45 over 360. I'm going to multiply both sides by the reciprocal. That's going to give me, basically change that to a 1 on the right side. So that becomes 1 over here. And if you multiply that out, you get 144 equals r squared. And if you know your perfect squares, you know that r is going to equal 12. Otherwise, you just take the square root of both sides to figure that out. All right, so our radius here is 12. This next section, we deal with logic and sets. It'll cover areas such as logical operations and statements, set relationships, and operations on sets. So this reads, if it snows, then the school is closed. So which of the following is a logical equivalent to the statement above? If it snows, then the school is not closed. If school is closed, then it snows. If it does not snow, then school is not closed. If school is not closed, then it does not snow. Now to be equivalent, the truth table of the two statements need to be the same. So we're going through the truth statement for all of these. So here we have, if it snows, then it will close. That's our premise that we have up here. So that's implication if, then. So if it's, I'll use S for snow. If it snows, then that implies that the school is closed. We'll use C for close. Now if we build the truth table, I'm going to put S first here and C. I'm going to fill these down with true, true, false, and false. Under close, I'm going to do true, false, true, and false. Then I'm going to build not S and not C. So not S and not C, that means basically the opposite. So if S was true here in the first row, not S is false. Second row was true, not S is false. And the last two rows, false and false for S, it's going to give us true and true for not S. And for not C, again, I'm going to do the opposite. So true is going to give you false. False will give you true. True will give you false. And false will give you true. Then I'm going to do the truth table for snow implies closed. School is closed. So the truth table for that. So true implies true. That is true. I'm looking at the S and C columns. So does true imply false? That's going to be false or implies. And does false imply true? That is true. And does false imply false? That is true. So that's the truth table for implies. S implies C. So if we look at A says if it snows, so S, then the school is not closed, so not C. So then I'm going to look at the S column and the not C column. So does true imply false? That is false. Does true imply true? That's true. And then does false imply false? That's true. And does false imply true? That is true. Okay, so that's not the same as S implies C. So those two columns are not equivalent. So if I look at letter B, if school is closed, then it snows. That's going to be C, school is closed, and that implies snow. So I'm going to look at the C and S columns. So there's true implied true, that is true. This F, false implied true, that's true. And then does true imply false? That's false. And does false imply false? That's true. Okay, so again, that does not match the S implies C column. So we'll go on to C. If it does not snow, then school is not closed. So if it does not snow, that's not S. Implies school is not closed, so not C. So I'm going to look at the not S column and not C column. So go down the different rows. Does false imply false? That's true. Does false imply true? That's true. Does true imply false? That's false. And does true imply true? So that's going to be true. So again, that does not match the true, false, true, true in the S implies C column. So let's try D. If the school is not closed, then it does not snow. So not closed is not C. Implies and it does not snow, so not S. So I'm going to look at the not C and not S column. Okay, so does false imply false? That's true. Does true imply false? That's false. Does false imply true? That's true. And does true imply true? So that's true. So those two columns match. So those are equivalent. When you're studying your logical statements, you'll come across converse, inverse, and contrapositive. And in this case, the not C implies not S is called a contrapositive. So I hope going through all these examples got you, better understanding of what the CLEP involves. So if you study all those areas, I believe you'll do well on the CLEP exam.